Hello everyone. Today I'm going to discuss about Newton-Raphson method. So let's get started. Here the aim of our experiment is to find the real root using Newton-Raphson method, and the equation is given as sin x is equal to x by 2, and also it is given that the root lies between pi by 2 and pi. So let's see how it works. Let's look into the theory. This method is generally used to improve the result obtained by other methods. To get the roots, let x0 be an approximate root of f of x0 is equal to 0. Now let x1 is equal to x0 plus h. Now if we expand using the Taylor series, we get the result like f of x0 plus h into f dash of x0 plus h square by 2 factorial into f double dash of x0 plus etc. is equal to 0, which we obtained by Taylor series. Now here the h, that is the step size, is given by minus f of x0 whole divided by f dash of x0. Here f dash is the first derivative of the function f of x. So that's how we get the step size h. If we substitute this equation in the equation of x1, we will get x1 is equal to x0 minus f of x0 divided by f dash of x0. For the xnth value, we have the xn plus 1 is equal to xn minus f of xn divided by f dash of xn into xn. This is known as the NewtonRaphson formula. To examine the convergence, we assume that f of x, f dash of x and f double dash of x are continuous. If f dash of x is not equal to 0, we can select an interval. Newton-Raphson method is an open approach where the optimum of one-dimensional function can be found. F of x is found using the initial guess of the optimal value without specifying lower or upper boundary values. Also, use the determine maximum and minimum of the function. So, Newton-Raphson is an much developed and appropriate way of solving. We have to code the Python program for the Newton-Raphson method. For that, let's look into the algorithm of the program. First, we have to define the function. Secondly, we have to read the initial guess or the initial value of, that is x1, from the user. Secondly, we have to define the step size, that is h is equal to 0.01. We can take any other value. It's not compulsory to take the value 0.01. And we have to read the number of iterations from the user, which is loaded in the variable n. Now a for loop is executed in which the I variable, which runs from 0 to the n. Within the for loop, we have to do the steps from step 6 to step 11. So under the for loop, we have y1 is equal to function of x1 minus h by 2. y2 is equal to function of x1 plus h by 2. Then the slope is nothing but the derivative of the function, is given by y2 minus y1 divided by h. h is the step size. So the x2 is given by x1 minus function of x1 divided by slope. Then we have to make the x1 as the x2. After doing this value, we have to print the value of x2 corresponding to the function f of x2. Now at the last, when the for loop is executed, we have to print the correct root as x2. Now let's look into the program. For that, we are using two header files, that is math and pylab. Then we define the function f of x, which returns the function sin x minus x by 2, which is the given function in the aim. Nextly, we take the value of x1 from the user. Then we set the step size at 0.01. Now we take the number of iterations from the user and store it in the n variable. Then we execute the for loop, in which the I value runs from 0 to n minus 1. Inside the for loop, we have y1 is equal to function of x1 minus h by 2, which is being called to the function which we defined in the beginning of the program, which returns the corresponding value and which stores in the value y1. Secondly, we have the function y2 is equal to function of x1 plus h by 2, which also calls the function and it returns the corresponding value. The returned value is then stored in the variable y2. Now we have to find the slope. Slope is nothing but the derivative of the function, which is y2 minus y1 divided by h, and it is stored in the variable slope. Now we have the function x2. We have the variable x2 is equal to x1 minus fn of x divided by slope. This is nothing but the NewtonRaphson formula. Now we have to set the x1 as the current value of x2. Now we have to print the value of x2 as x2 and function of x2 as function of x2. After the for loop execute for the n minus 1 term, it comes out of the for loop and we print the root corresponding to, which is x2. Here it is the output of the program. Here we could see that we firstly enter the value of x1, that is pi by 2. Secondly, it asks us for the number of iteration. Here I have given the value 10, so it iterates for 10 times. So the first for loop, when the first for loop executes, it prints the value of x2 as 2 and function corresponding to it, and the loop continues for 10 times, and after the for loop is executed, it comes out of the for loop and it prints the value of x2, which is 1.895494, which is the correct root of the given data. So that is all about the program. Hope you all understood the program. Thank you.